welcome everyone to our quarterly webinar. Today's topic is very specific to our respirable crystalline silica and where we are, where we stand, and what you need to be done here. So we have two speakers today. One of our speakers today is Tom Bielema. Tom's a regional director for Safety Controls Technology, a company called SCT. As regional director, he assists in the development and implementation of comprehensive safety and health solutions to the industry. FCA International entered into an agreement with SCT for them to provide comprehensive industrial hygiene services, specifically air monitoring, to help develop a database of objective data to support our contractors with their written exposure control plans. Tom's going to be providing us an update on what we've done so far, what the object is, and what we're looking to do, and what we're looking to have when we're all done this program. So we'll hear from Tom shortly. At this time, I'd like to introduce our core speaker. Michael Hartnett was a safety professional at Optimum Safety Management. He's been involved in the industry for years. Used to be part of the IUPAT. After earning his bachelor's degree in labor safety and his master's degree in educational technology, he brought his trade experience to the safety side of the business. Mike is plain flat out, he is the key liaison for our safety consultant. Optimum Safety Management is our safety consultant for FCA. They've done a phenomenal job for us, and Mike is the liaison to our FCA International Safety Advisory Committee. So at this point, I'd like to turn it over to Mike and let him start off with what we're doing and where we stand from the silica standpoint. Mike?
Thank you, Bob. I'd like to welcome you all to the Silica webinar, and why don't we get right into it? I'd like to start off by pointing out some of the value that FCA is bringing to their members through their offerings. First off are their Toolbox Talk program. Over 200 toolbox talks in both English and Spanish with a preset 52-week schedule that's available. If you'd like to receive a key to that, to access them, you can contact Arlene Schonder. Also, every month, FCA International publishes a safety newsletter. That includes a safety update from FCA, a couple of different focus of the month articles, and then a couple of blogs on current safety topics. There's a lot of good value in there, and it's good for you guys to take a look at. In addition, there's a safety helpline. All inquiries that are called in or emailed to this line are confidential and receive a response within 24 hours. Generally, it is myself who is responding to those. So let's look at the outline. We're going to be looking at the respirable crystalline silica standard in the construction industry. Okay, we're going to look at the scope of the new OSHA standard, which isn't so new anymore. We're going to look at exposure control methods. We're going to look at FCA's Objective Data silica assessment and get an update as to where we are in that. We're going to talk about respiratory protection, written exposure control plans, what the responsibilities are for medical surveillance, and for record keeping. So why are we talking about respirable crystalline silica, and why did this new standard come about? Well, they say about 2.3 million workers are exposed to silica in their workplaces, and the majority of them, about 2 million, work in construction. Also, since '68, too many people have died from silicosis, which is the medical condition that crystalline silica can cause. Also, they say that 200 workers die from silicosis each year. That's why we're looking at the scope of the new OSHA standard. That's why we're looking at this standard. So what does the standard entail? Well, there's been a standard of silica since OSHA was first put into law. But initially, construction had a permissible exposure limit, which is the amount of exposure an employee was allowed to be subjected to over an 8-hour time-weighted average of 250 micrograms. Well, today, since last year in September, it's dropped to 20% of that, so 50 micrograms per cubic meter. And while the old regulation was a half page, the new regulation is 30 pages long. In addition, at about the same time, the maximum penalties that OSHA was allowed to give for citations has changed. It went from serious, used to be around $7,000, and now it's $12,934. Repeat and willful are $129,000. Now, these are also tied to inflation, so they will go up automatically each year. So the occupational, I'm sorry. The Occupational Safety and Health Standard, 1926-1153, applies to all workers with exposures to respirable crystalline silica in the construction work. I'm sorry, I have something blocking my screen that I'm trying to move off. There we go, that's better. So there's everybody that has any occupational exposure to respirable crystalline silica is covered underneath this standard, unless the employee exposure will remain below action level in any foreseeable condition. This is rather unlikely in any situation where there is any respirable crystalline silica exposure at all. The action level is the concentration at which it becomes an issue, where the standard comes into effect. So the action level is at half of the PEL, that's 25 micrograms per cubic meter. So I can't do a demonstration of what that looks like here, but when I do these courses live, we generally take a Splenda packet or equal. We can't use sugar because sugar is too large and won't work for this demonstration. If we take that packet of Splenda and pour it out on a desk, and then use a business card to cut it in half, we have to cut that in half 16 times before we can get to a representation of that 25 micrograms. I've tried this, and in my demonstrations, I've never gotten beyond 12 times of splitting it and being able to see any accumulation left on the desk. So this 25 micrograms is a very, very small amount. The PEL, which is set at 50 micrograms per cubic meter, also calculated as an 8-hour time-weighted average, is a level of concentration that we are not allowed to expose our employees to above. Okay, so the standard requirements has 6 basic aspects. You have the requirements for a competent person, requirement for exposure assessment, requirement for specified exposure control methods, written exposure control plans, medical surveillance, and record keeping. So we'll go over each of those. Your exposure control methods are going to start off first with your competent person. So a competent person is a common definition within the OSHA lexicon, and it pretty much always means the same thing. Capable of identifying an existing and foreseeable hazards in the workplace, and having the authority to take prompt corrective measures to eliminate or minimize them. So somebody without the ability to identify the hazards cannot be a competent person. And somebody who doesn't have the authorization to take prompt corrective action also cannot be a competent person. It requires both parts of that definition for them to be a competent person. So the requirement for the competent person is that they have the knowledge and ability to make frequent and regular inspections of the job site, materials, and equipment to implement the written exposure control plan. Does this mean that that competent person has to be on site? It's a question that's been asked many times. And the answer is no. They don't necessarily need to be on site all the time, but they need to be there to implement the written exposure control plan and to make frequent and regular inspections of it. So a superintendent could possibly be the competent person, but they need to make sure that they're making it to the job daily and that they are implementing that written exposure control plan. So it really becomes a question of bandwidth as to who needs to be the competent person. Best practice is to have the foreman on site be the competent person, or have somebody else on site be the competent person so they can inspect and make those assessments regularly. So the specified exposure control methods. Specified exposure control methods are generally talking about Table 1. Okay, Table 1 has 18 common tasks in construction industry that produce respirable crystalline silica. They're going to go over what engineering controls are required. They're going to specify what work practice controls are required. And they're going to specify what respiratory protection is required, if any is. Okay? And we can follow that as long as we fully and properly implement the tasks on Table 1. We can perform those tasks without exposure monitoring. Okay? The purpose of Table 1 is to lift the burden of exposure monitoring for specific tasks. They took the 18 most common tasks that they thought they could use, that they could define good engineering, administrative, and PPE controls, and they defined those. And as long as we follow those specifically in those tasks, exposure monitoring isn't required. Some of these tasks which you may be working with are stationary masonry saws, handheld power saws. Handheld power saws for cutting fiber cement board with a blade diameter of 8 inches or less. Walk behind saws. Drivable saws, which most likely finishing trades aren't going to be using, but rig mounted core saws or drills could be something that you see as well. Handheld stand-mounted drills, including impact and rotary hammer drills. Jackhammers and handheld powered chipping tools. Handheld grinders for motor removal. Handheld grinders for uses other than mortar removal. And walk behind milling machines and floor grinders. So these were the ones I believe most likely, these are on Table 1, that finishing trades are most likely to run into. I took off the earth moving equipment and anything that had to do with grinding asphalt, and I believe that these pretty much cover what you may be running into. So let's look at what is required for one of these. Walk behind milling machines and floor grinders. Okay, this is on Table 1. It specifies what engineering and work practice controls are required. You can use a grinder with a commercially available shroud or cowling with a dust collection system, or you can use a grinder equipped with an integrated water delivery system. So when it says integrated, it means it needs to be a part of the machine. So having somebody there with a Hudson sprayer spraying down does not fulfill Table 1. Now, that doesn't mean that you can't perform the work in that fashion. You can. But then the burden of the assessment, the exposure assessment, still needs to be fulfilled. Because once again, Table 1 only lifts that exposure assessment requirement. You can do Table 1 instead of exposure assessment, but only on those tasks that it covers. So when we're working with the equipment that has a commercially available shroud or cowling with dust collection system, the dust collector must provide an airflow recommended by the tool manufacturer or grader and have a filter with 99% or greater efficiency and a filter cleaning mechanism. Then you have to operate the tool in accordance with the manufacturer's instructions to minimize the dust. You also have to maintain that piece of equipment according to what the manufacturer says. And you need to use HEPA filtered vacuums when cleaning holes, okay? When you follow these instructions, the required respiratory protection, which is divided generally into less than 4 hours or more than 4 hours, indoor and outdoor. With this specific one, indoor or outdoor is the same, and less than or more than 4 hours are the same. Either way, if you're using this equipment the way it's meant to be used, there is no requirement for respiratory protection on it. So let's look at another one. Jackhammers and handheld powered chipping tools. Okay, we can use a tool with a water delivery system that applies a continuous stray or stream of water at the point of impact, or we can use a tool with a commercially available shroud or dust collection system, which provides airflow recommended by the tool manufacturer or grader. Also has to have a filter, 99% efficiency, and a filter cleaning mechanism. You also have to operate and maintain it in accordance with the manufacturer's instructions. So when we're doing a handheld powered chipping tool, we have different requirements here depending on whether it's indoors or outdoors, and more or less than 4 hours. So if we're outdoors and we're doing it for less than 4 hours and we're following the instructions above with the engineering and work practice controls, then we do not need any respiratory protection. But if we're doing it outdoors for more than 4 hours a shift, we need respiratory protection with an assigned protection factor of 10. Question here is, what type of respirator offers an assigned protection factor of 10? Well, we can go with a half mask face filtering face piece, aka the dust mask, and that has an APF of 10. Or we could use a half mask respirator with particulate filters, which is also an APF of 10. So when we go to indoors with this piece of equipment, then regardless of whether it's more than 4 hours or less than 4 hours, a respirator is going to be required.
Hey, Mike, this is Bob.
Yeah.
Just to clarify for my own case here. So what you're saying is a basic N95 dust mask meets the APF 10?
Yes, it does.
Okay. Okay. Just wanted to make
sure. As long as it's being worn correctly, we need to make sure that we're fully implementing a respiratory protection program, which we'll discuss later. But a dust mask does provide APF 10 protection.
Thank you, sir.
You're welcome. Okay, other considerations that must be in place when you're implementing Table 1 is you have to minimize visible airborne dust tasks. Indoors or in enclosed areas, you need to have a means of exhaust. And when using wet methods, you must apply proper flow rates. So as far as proper flow rates, I'm sure that we've all seen tile setters working at their saw, and it has water going to the blade, and the longer they cut, the more particulate gets into that water, clogs up that filter, and by halfway through the day, dust is flying out of there. That is not maintaining proper flow rates, okay? Proper flow rates means that if you're recycling that water, you may have to refill that water instead of recycling it the whole time. And we need to make sure that when equipment is not keeping that dust down, that we then reassess it and find out what's going wrong. Whether that means a filter needs to be changed, whether that means the water needs to be changed out. We need to look and find those answers. That's part of the responsibilities of the competent person on site. So, alternative exposure control methods. We're going to look at what the different ways of looking at the assessment, right? So if your task is not listed on table 1, such as sanding drywall, spraying paint that contains silica, hand mixing, and other tasks that you might be running into. Or if table 1 isn't fully and properly implemented, if you're using a tool that doesn't have an integrated water supply, but you're using somebody that's standing there with a Hudson sprayer spraying on top at the point of impact, that's not allowed on table 1, but it is allowed. Once again, table 1, the only thing table 1's going to do for you is lift the burden of the exposure assessment, okay? So if you're not implementing table 1 fully and properly, you'll still need to do an exposure assessment. So no employee may be exposed to an airborne concentration of respirable crystalline silica in excess of 50 micrograms per cubic meter, calculated as an 8-hour time-rated average. The exposure must be assessed for each employee at or above the action level. So these are some of the tasks that are not going to be on table 1, right? And those are shown in red. Those that are in table 1 are shown in blue. So if you look under sign and display, the second one is chipping tools, which we went over. That's on table 1, and it's number 10, right? The handheld grinder is on table 1, and it's number 12. But there is not any list anywhere on table 1. Is there abrasive blasting, wall repair, mixing joint compounds, sanding drywall compound, shot blasting concrete floors, or sweeping existing site conditions? These are exposures that your employees may very well be dealing with, which will then put responsibility on you to make sure you're following the standard. So how do we do an exposure assessment? There are 2 options, okay? The first option is called the scheduled monitoring option. And the second option is called the performance option. We'll go over the scheduled monitoring option first. This is where the personal breathing zone air samples reflecting the exposure of employees on each shift for each job classification in each work area for a representative fraction of the employees. And we're going to test to see if they're above the action level or the PEL. Okay. What is a representative fraction? Generally 25%. So at your initial monitoring, if it's less than the action level, then you can discontinue the monitoring. If it's at or above the action level, but less than the PEL, then you have to improve your work practices and your engineering controls, and then repeat that monitoring every 6 months. If you're at the PEL or above, you have to repeat that monitoring every 3 months. Okay? So when can you stop doing that monitoring? I mean, we're improving our engineering controls, we've gotten better tools. We've improved our administrative controls. We've trained our workers in how to best beat this and make sure they're not being exposed. And we think we've dropped it below. When can we stop this? If you get 2 consecutive exposure monitoring results within 6 months, but more than 7 days apart, that are below the action level, then you can discontinue the monitoring. But whenever there's a change in production, process, control equipment, or work practices, you have to start again. Whenever you're going to perform this monitoring, you have to provide the employee's representative an opportunity to observe any employee exposure monitoring. Also, there are employee notification requirements. You have to notify each affected employee in writing of the assessment results within 5 days after receiving the laboratory results. Okay? They have to receive it in writing, whether it's positive or negative, whether they are above or below. You need to make sure that they are notified. If the exposure is above the PEL, then you also have to provide written notification of what corrective actions you'll be doing to reduce that exposure below the PEL. So that brings us to the performance option. The performance option is where you use any combination of air monitoring data or objective data sufficient to accurately characterize employee exposures to crystalline silica. Okay. Examples of objective data are air monitoring data from industry-wide surveys, such as what FCA is working on right now. Okay. You can also use calculations based on the composition of a substance, area sampling results, and exposure mapping profile approaches, and Historica air monitoring data. So that brings us to FCA Objective Data. We're going to hand it over to Bob now to discuss what the objective data that they're trying to find, what performance option as far as assessment that they're working on getting for you guys. Bob, you want to take over?
Yes, sir. Thank you, Mike. I appreciate it. As I indicated earlier this year, FCA entered into an agreement with SCT to provide comprehensive industrial hygiene services, a la the air monitoring testing, to develop a database of objective data that we'd be able to use and all of our contractors could use. So I'm going to ask Tom to give us an update on where we're at, what we've done so far, and where we're going from here. So at this point, I'd like to turn it over to Tom Bielema. Tom?
Hey, thanks, Bob. Thanks for having me on here, guys. I know I'm a guest speaker, and Mike, thanks for letting us carve out some time here to give a little bit of update. So Mike's done a great job setting up the standard for you and talking about the exposure assessments and the objective data and table 1. Bob and the FCA and their foresight, they saw there's some things in table 1 or there's some things that you guys do every day that are not included in table 1, and they're common tasks within the industry. So OSHA tried to frame common tasks in construction, those 18 common tasks, and put them in table 1. What we're trying to do is create a objective database for FCA type of activities. And so if we could go to the next slide. So what we did is we started, again, Bob, and put a committee together, and we looked at the different tasks that each kind of division of the trades are doing. And one of the things, and where we started, is with drywall. And so we looked at table 1, and there's not anything that really specifically puts drywall into table 1. And what we wanted to do is try and help you all make decisions. So the point of, again, what OSHA did with table 1, they'll help you with controls, they'll help you with work practices, they'll help you with PPE, and you don't have to make further decisions. All of that is based on data. It's based on data. It's not based on somebody's opinion. It's based on data. So what we're doing now with the FCA and the partners within the organization is we're defining those parameters. So we're looking at different jobs, real world applications. We're collecting the data, we're collecting the variables, so we can use that data to get to all the membership to be able to say, if you're doing this like in similar activity, here's the decisions that could be made for you. Here's the controls you need. Here's the exposures that you would anticipate. Here's the protective equipment that you may need. And so our data is coming in, and we're trying to put that into, when we get done, we're going to roll that up into an easy format that you guys will be able to use, again, and try not to make this too plain, but to make it look like a playbook. So you're there, I need to do this task, you'll be able to reference the playbook and say, this is the data that supports our decision, and then you're justified in going forward with that. As long as the parameters are the same, as long as the conditions are the same, that will be useful data for you. There may be some nuances with job-specific conditions that may be a little bit different, but we're trying to put all of those variables in there so you can see exactly what we were doing. So to not read the data to you, I want to tell you, we're trying to get a compilation of many different type of conditions. So we've seen big jobs, we've seen little jobs, we've seen large contractors, small contractors, big crews, little crews, and we're trying to make sure that we're hitting some of those variables. If it's a 2-man or a 4-man crew going out versus a 32 person crew that's out there, then we're trying to see the differences in those. So we've seen different manufacturers in materials, and we've seen different techniques. We've seen hanging and mixing, taping and finishing. We've seen even variability within there, folks that hang their own, and then we'll use pre-mix, pre-fill, and tape, and then finish either the next morning or that afternoon. And then we've seen folks that segment those tasks: hanging crews, pre-fill crews, tape crews, and then finish crews. So we've seen folks finish for a couple hours a day, and folks finish, and by that I mean sanding, for a majority of the shift. So the results we're getting in are fairly consistent. We're looking for both respirable dust and respirable dust containing crystalline silica. And the concerning thing, and the point of the webinar today, is the respirable dust containing silica. So I'm happy to tell you the data that we have right now in hangers, folks mixing, tapers, and finishing, all of those results have come below the action level in our drywall jobs. We've had a couple on the finishing side, on the sanding side, that have gotten close to that action level, but we have not exceeded the action level at this point. Respirable dust correlates pretty directly with that. You know, the higher the silica exposure in the respirable dust containing silica sample, usually the higher the respirable dust too. And this is one, again, we've seen very consistent results. We've had at least one person on the finishing side, so somebody sanding for a majority of the shift, had exposures that were right there at that permissible exposure limit. What that tells us is we need to put in additional controls, either engineering controls, vacuum sanders, dust collectors, things like that, or administrative controls where we can limit the amount of time of exposure. And so that's what we're wrapping up. So we're still looking for opportunities there. Get with either myself or Bob if you're interested in participating in some of those opportunities. Next slide, if we could. So this is kind of, you see that picture I put on there in the future. This is where we're going. We've got a few jobs in the commercial paint side that we're collecting data from, and we're still looking for other opportunities. The things that Bob and his team, along with we at SCT, we looked at those opportunities again out of Table 1. And so if we're on the commercials paint side, we're looking at applying and sanding and grinding on paint that's either 1 to 2% or greater than the 2%. We're looking at dry fall. We're looking at fireproofing. Usually that's on the mixing side of that, but it can be in the cleanup side too, depending on contractors' preferences. So again, we're trying to find the right jobs with that. So if there's opportunities that you may have and you're interested in participating, let Bob know, and we'll see if it meets those parameters. That's helpful to the tasks that we have at hand here. On the industrial, we've got some blasting data. And again, that's not one that's in table 1, but we also want to do some grinding. This is more of that light industrial. So interior columns and beams and fire escapes and those type of things, stairs that we're looking to do, and then grinding on that paint as well. We're looking to identify what that exposure would be to that respirable crystalline silica during those exposures, and again, help you guys make decisions. Then the last is the flooring. Many of those tasks are going to fall within table 1, as Mike pointed out. We're trying to pick up some of those other things if they're longer term. OSHA just came out with a new set of frequently asked questions, and they talk about mixing small amounts of mortar, which would be similar to leveling compound, things like that. That small amounts is the part that makes folks uneasy, because what's that mean? That's a little bit of a personal preference of what that means. So we're looking for data again for mixing, patching, brushing and edging, the areas where there could be exposure that are not already identified in table 1. So our team is working with your team. What we're doing is we're putting together data for that. So again, what I've got on the bottom, we're trying to find the right jobs that fit the study. If you're interested, please let us know. The more data that we can put within this, with the limited resources we have, the better it's going to be for everybody. We're trying to make, similar to a table 1, trying to give you data that helps you make those decisions, and you don't have to do it all on your own.
Okay, is that it, Mike? Or Tom?
Yes, sir.
All right, thank you very much, Tom. Appreciate that. While I have both of you on the phone, on the there, I have a crazy question, and it's sort of a clarification piece. I know that we need, if you've identified a task that produces respirable silica, we need to have a written exposure control plan. My question comes about, and it's really for a clarification piece. Is a company also required, in addition to a written exposure control plan, required to have a written silica program? Tom?
So I can answer that one. By the regulation, the written piece you will need is a written exposure control plan developed by a competent person, reviewed annually, and Mike covered that. Most folks will have a comprehensive silica program. It is not required by the standard. But in my terms, this is the framework where you lay out what you want to do. This is the framework where you lay out how you're going to train your folks, how you're going to get your tools and equipment. It's going to give an overall approach that's going to wrap in your silica efforts, or your silica exposure limiting efforts, different than just the 4 elements that needs to be on the job-specific written exposure control plan. So not by regulation, but in practice, I think it's the best practice, Bob.
Okay, and that kind of makes a little bit of sense. What we found is the request to contractors for that type of a program has been coming from construction managers, GCs, and the like. So again, it's something that it's good for them to have. It'll answer a lot of questions, especially for GCs and construction managers, but it's not required by the plan. Correct?
I'll tell you what I tell my clients. This is an opportunity for you to show the commitment you've made to safety and health. So as a general contractor, construction manager, owner, whoever it is that's looking at you and you're applying your bid packet, I want to have this overall program that encompasses my written exposure control plans, my training, my medical surveillance, PPE, all these things. And because I want to give them the certainty that they picked the right guy. They picked the right contractor that's prepared to do this, and we're not going to create problems on their job site or risk to other trades that may be in the area.
Well, thank you, Tom. I really appreciate that. And by the way, Tom actually spent 12 years with OSHA out of their Pretoria office as the compliance and health officer. So we appreciate that.
I was 23 with OSHA, 12 years in the field, and then another 11 in the office.
Outstanding. So.
Well, thank you very much. I appreciate the update. I'm really looking forward for getting this objective data together. I think it's a fantastic value that you've you've gone out there and worked on, and it's going to be wonderful for your membership when it comes through. So keep up the good work. Thank you very much, Tom. Thank you, Bob.
Thanks, Mike. Back to you, sir.
All right. So now we're going to move on to methods of compliance. Once we've done our assessment and we've found out what the exposure levels are, what are our responsibilities out there in the field? Well, you must use engineering and work practice controls to reduce and maintain that exposure below the PEL. What does that mean? It means you can't just rely on respiratory protection. You can't say, well, we put them in a respirator so we don't have to worry if it's above the PEL, because the respirator will bring it back down below. That's not an acceptable option that's not an acceptable exposure control method, okay? The only time that that's allowed is when the employer can demonstrate that controls are not feasible. And let's be clear here, feasible and inconvenient are two different things, okay? Not feasible and inconvenient are not to be confused in this situation. If all feasible controls are not sufficient to reduce that exposure below the PEL, then they still have to be reduced to the lowest feasible level and then implement proper respiratory protection. So one way or the other, we need to make sure that that employee is protected, and we can't just rely on the PPE to do it. And there's also tools that are out there to help you comply with this, whether it be the vacuum system with the sander or using, not only engineering controls, but administrative controls. With limiting the amount of time people are doing it or using wet methods instead of dry methods. There's a bunch of different options out there for you. Okay, housekeeping is another concern related to silica. Okay, one that almost every trade deals with is you're not allowed to perform dry sweeping or dry brushing or use compressed air to clean clothing or surfaces that contain respirable silica. You must use wet sweeping using a sweeping compound or sweeping with water, or you need to use a HEPA filtered vacuum, okay? And when you use wet methods to contain the dust, you must have a proper cleanup of slurry prior to it drying. If you leave the problem for the next contractor, it still opens you up to liability, and it's not the right thing to do. Okay, so make sure that if you're using those wet methods and creating slurry, that you're cleaning that up. So respiratory protection. Respiratory protection is an important part of the standard, and a lot of the tasks covered in Table 1 require respiratory protection. And where it's specified in Table 1, or if you're not following Table 1, or the task isn't on Table 1, if the PEL is when you're gonna be over the PEL and still implementing engineering controls and work practice controls, you must use a respirator, and you must have a compliant respiratory protection program, okay? 1910-134 lists those requirements, including training, including medical clearance, including fit tests on an annual basis, and training on an annual basis. So the written exposure control plan. Written exposure control plan is required anytime you're going to be exposing your employees at the action level or above, okay? So they're pretty simple. They're not complex. They are required for all tasks that involve exposure to silica. So let's go back to Table 1. What if we have, we're following Table 1, so we should be all good, right? Wrong. Table 1 lists the requirement for exposure assessment, and that's all it does. If you're following Table 1, you still need written exposure control plans for those tasks if is going to be at the action level or above. So all the tasks or all the written exposure control plans are going to require 6 items. A description of the task, and this should include whether it's indoors, whether it's outdoors, whether it's an enclosed area, whether it's an open area, and what the task is, what the material is going to be that's going to be manipulated and causes the exposure. Okay, what engineering controls are going to be used to control it? What work practices are going to be used? What respiratory protection is going to be required? What housekeeping measures will be utilized? And the procedures that you'll use to restrict access, not ACEs, access to work areas.
Hey, Mike, I have a question
Yeah.
for you on the exposure control plan. In addition to the control plan, is it required or just helpful to have the material MS or SDS sheets and or the objective data or air monitoring data that you're using to justify your written exposure control plan?
Okay, so your objective data or your monitoring data does not need to be on site.
Okay.
The exposure control plan does need to be on site. We'll talk about the record keeping requirements a little bit later, which will include your objective data or your assessment data and how long that has to be kept. But that does not need to be on site. The written exposure control plan does need to be on site, and the SDSs would need to be accessible.
Very good. Thank you, sir.
In construction, it's not required that the SDSs be on site, but they need to be readily accessible. They can be kept in a centralized location. But in the modern day and age, with everybody having a smartphone, really the best practice is going to a digital SDS where everybody can get access to that. That way everybody has the opportunity to look at those SDSs when on demand. Okay, so this is a sample written exposure control plan. This comes from the OSHA Small Entity Compliance Guide for respirable crystalline silica, which is a very good document. It's about 90 pages and it has a lot of good information in it. I know that the FCA website does have a silica list of silica resources, including the Small Entity Compliance Guide. They also have written exposure control plan templates for both drywall and painting on the FCA website under Resources Silica. So those are some of the resources that FCA has that you can go and look at. But let's take a look at this written exposure control plan. Okay, first as the company name and the person completing the plan. Okay, those are important. Description of the task, demolishing concrete and tile floors inside homes or public buildings using a jackhammer. You can write these written exposure control plans so that they can apply in multiple locations, but you want to make sure that they're specific enough to fulfill the requirement. So control description, lists using a jackhammer with a commercially available shroud and vacuum with a 99% efficient filter and a filter cleaning mechanism, and the use of a portable fan to exhaust air and prevent buildup of dust. If you look at this written exposure control plan and you hold it next to the slide we looked at earlier that shows what the table 1 says about jackhammers, you'll see the vast majority of this is on table 1. Use of a portable fan to exhaust air and prevent the buildup of dust is not, but it is required when you're working inside, as we talked about earlier, to use some way to exhaust and prevent buildup of dust. So your work practices are to correct your shrouds and hoses, make sure they're not damaged, make sure your hoses don't become kinked or bent. Uses a switch on vacuum to activate filter cleaning at the frequency recommended by the manufacturer. Replace the vacuum bags as needed to prevent overfilling. And use a jackhammer and vacuum controls according to manufacturer's recommendation. Respiratory protection is APF 10 and following your written respiratory protection program. Your housekeeping is containing silicone work surfaces cleaned with wet methods or a HEPA filtered vacuum. They state we're not going to use compressed air or dry sweeping, and dispose of used vacuum bags in a container and keep the container sealed. And then the last is procedures used to restrict access to the work area. So here they have that they're scheduling it so that employees that are engaged in the task are in the area and only those employees. It's not the only way to do it. Just like they have caution tape, they now have silica tape that I believe it's orange and it says silica hazard, do not enter. You can put up that and restrict the area that you're working, utilizing that. So the 6 items are your description of task, your control descriptions, both your controls and your work practices, your respiratory protection, your housekeeping, and your procedures used to restrict access. So what are the other requirements related to written exposure control plan? First, they need to be reviewed and evaluated at least annually. By who? By a responsible individual within your company, whether that be the competent person or management and ownership. They must be readily available to each employee. Okay, that's one of the reasons they need to be on site. Not only do they need to be on site, but each employee that's going to be exposed to that silica has the right to read those, to see them, okay? And the competent person must make frequent and regular inspections of the job site, material or equipment, to implement the written exposure control plan. Medical surveillance. So medical surveillance is going to be required anytime you have an employee that is going to be wearing a respirator 30 or more days a year. And here's the important part: to protect against silica. Okay? If they're wearing it 30 days a year to protect against silica, they need to be entered into the medical surveillance program. Now, it's not a question of how long they're wearing it to protect them from silica. If they're wearing it for 5 minutes in a day, that counts as a day. So if they're wearing it 8 hours in a day, that also counts as a day. But if they're wearing it for reasons other than silica, then it may not count that day unless they're also wearing it for silica, okay? So each employee required to use a respirator for protection to silica exposure for 30 days or more per year need to be put into a medical surveillance system. Okay, it needs to be available at no cost to the employee. It needs to be available at a reasonable time and place for the employee, and it needs to be performed by a physician or other licensed healthcare professional. What does medical surveillance entail? First, we start with a medical exam within 30 days of initial assignment. Okay, so this is something that you want to look forward towards. You want to do a little bit of planning on this. Look at what tasks you have, what job roles you have, where it's likely somebody's going to be performing silica, tasks that have silica exposure with a respirator 30 days or more a year. If you pick those people within 30 days of their initial assignment, you need to have them perform a baseline medical exam. It's going to have a medical work history with past, present, and anticipated exposures to silica, history of any respiratory system dysfunction, any history of tuberculosis, smoking status and history. It's also going to give a physical exam, chest x-ray interpreted by a NIOSH certified B reader, which is, it needs to be interpreted by somebody who's been trained specifically to look for silicosis, okay? And the reason that they're calling this a baseline medical exam is because all future exams will be looking back at this material to see if there is a progression of silicosis. They'll also require a pulmonary function test, which is required during a medical clearance for respirators anyways, so they should already be able to pass that without an issue. They need to be tested for latent tuberculosis infection and any other test deemed appropriate by the physician or licensed healthcare professional. After the initial, we require periodic examinations, at least every 3 years, and more frequently if recommended by the physician or licensed healthcare professional. Now, when is it going to be recommended more often? 2 x-rays are looked at and there seems to be a progression of silicosis. They may very well ask for a more frequent periodic examination.
Hey, Mike, before you go any further, I got 2 questions.
All right.
Regarding that. The first question, obviously with our transient workforce, we have people coming and going. You talked about the retesting in 3 years. So if you have an employee that are with you for a year, you let them go, are you still responsible to do testing with them after they're no longer with you?
I do not believe so, but I'm going to have to look that up and get back to you on it. That's a good question.
Okay. The second question, you talked about with the, you have a baseline and then you have additional testing that they would review against the baseline. If an employee already had a baseline with a different company prior to coming to you, is that baseline used with that, or do you have to establish a whole new baseline with that employee coming to you?
You would want to establish a baseline for that employee coming in, but the past records that had been taken may be brought in, I'm sure would be utilized by the physician to see, and that would be up to the employee to bring those records with them. Now, it's always, for liability reasons at the very least, you should perform that baseline so you know what damage has been caused while employed by your company.
Very good. Thank you, sir.
You're welcome. Any other questions on the medical medical surveillance? I know it's one of the more challenging aspects of the Silica Standard. All right, let's move on to record keeping then. So it's your requirement to maintain accurate records, okay? Air monitoring data, specifically the dates, tasks, sampling and analytical methods, number, duration, results, samples, lab use, PPE worn by employees, names, social security numbers, job classification. All this information needs to be kept. Same with the objective data. If you use FCA's data to prove that you are going to be below the action level, you need to make sure that you keep that data. And medical surveillance, also anybody in that medical surveillance program, all of that information needs to be kept as well. Okay? They must be maintained and made available in accordance with the OSHA standard related to record keeping. The exposure records need to be preserved and maintained for at least 30 years from the point of gathering. And any medical records, such as the medical surveillance, for each employee needs to be preserved and maintained for at least the duration of the employment plus 30 years. That's a long time, but that is a requirement for motion. So right now we're going to review what we went over. If you have any questions about any of these, we can touch on them now again. The standard requirements are for a competent person. Competent person needs to have the ability to assess and to be able to predict what hazards are going to be present. They also need to be able to mitigate those hazards, have the authority to mitigate those hazards. That authority comes from their employer, and that authority must be given by the employer for them to be a competent person. Next, the exposure assessment, where we have the scheduled monitoring option and we have the performance option. Performance option being the objective data that FCA is building right now. Also, Table 1 is also considered part of that. Now, your specified exposure control methods, your specified exposure control methods, starting with engineering controls, administrative controls, PPE. Your written exposure control plans that must be on site. They need to be reviewed annually and approved. Your medical surveillance, which is required on anybody wearing a respirator 30 or more days a year for protection from silica. And your record keeping requirements, which most of them are for 30 years, except for those that have to do with medical records, which are 30 years plus the time that the employee is with you. So what's next? What do you have to do next as an employer? Well, we have a silica checklist here. And so you're aware, there's a PDF version of this presentation that FCA has. If you email Darlene, she'll be able to send you a copy of this in PDF form. The entire presentation, not just this slide. So on this slide, you'll see a list of 10 things that should be being performed to verify your readiness. Okay, first you identify all your silica generating activities. Then you develop a strategy for compliance, to see where your highest hazards lay and how you want to go about attacking it. You need to develop a corporate silica safety program. Like Tom said earlier, we want to make sure when we offer a product to general contractors, we want to make sure that we're offering a fully inclusive safety program. We want to make sure that we not only have written exposure control plans, but a silica safety program. Next one is implementing new engineering controls. If you have bought the equipment necessary to comply with the standard. Conduct initial air monitoring for the scheduled monitoring option to determine your exposure levels. Develop your written exposure control plan. Make sure your workers are trained on silica risks and exposure controls. Provide your respiratory protection for your workers, including a respiratory protection program that includes all the requirements for that. Provide your initial medical exams for highly exposed worker and identify and mark your regulated areas. So last but not least, I'd like to invite you to next week's, the September monthly safety call. We have calls every month, the fourth Tuesday of the month at 2 p.m. where we call in, where you call in and we talk about what finishing contractors can do to protect their members. It's open to all FCA members, and other than summer months, it happens on the fourth Tuesday of every month. at 2 p.m. Central. So September's topics are going to include proper respiratory protection for tasks including silica, nuisance dust, and latex spray paint, how to implement and develop your internal company respiratory program, and how to develop your internal hazard communication program and training, which is very difficult within the finishing trades. So you can join by computer. We have the link there and the phone number there as well. Does anybody have any questions?
Hey, Mike, there is one question from the audience that didn't get answered yet, and it actually went back to Tom's stuff on the air monitor testing. The question is regarding abrasive blasting, and the question is it your goal to collect data for blasting of concrete by both water injection or vapor blasting, as well as steel?
I think when we initially, sorry, this is Tom. When we initially framed this on the industrial paint side, I think we had envisioned, like I said, stairs, fire escapes, interior columns where we're removing paint from a surface, paint that could contain silica, and then of course we could make it respirable in that fraction. I think most folks in the industry are away from using river sand or just silica-based abrasives. So I think that lends to a good question that I think Bob and I might need to circle around back on, is see what some of those alternatives are that are out on concrete, finishing, polishing, etching, those kind of blasting operations, and see if we need to collect some data in the study there to show those engineering controls if they're working. If they're working as they're anticipated to do.
Okay, and one last one, and it'll probably fall under the exact same thought process, is about how about blasting crushed glass on concrete surfaces? Well,
it's the organic chemistry side of me says that crushed glass, or that glass, is going to be an amorphous form as long as it's fully converted from the quartz to the amorphous form. So a little bit different type of silica, not the crystalline silica that we were looking for. But anytime you take any abrasive against the concrete, you could have the exposure come from the surface that you're blasting against. So if it's concrete or CMUs or tiles or anything like that that is silica based, then you could have exposure there as well. So another good point to show where those exposures could come in the abrasive blasting could not just come from the substrate, but can be from the surface as well.
Very good. Any other questions? Okay. Mike, do you have anything else that you need to add, sir?
No, I just want to thank everybody for attending and listening, and remind them that if you want copies of the slides, you can reach out to FCA and they can get it for you. And thank you very much, Tom and Bob, for all you've added.
Thank you very much, everyone. We appreciate your time. Am I hearing someone in the background? Okay, very good. Well, first of all, I want to thank Tom and Mike for the tremendous information. We really appreciate it. You did a great job today, and some great information. I do recommend anyone who can to attend next week's safety call. I think it's going to be a very positive one. This is something we're hearing from a lot of contractors that need to update and or develop additional stuff for their respiratory and or hazard communication program. So again, gentlemen, thank you both very much. And just to reiterate the last thing, a lot of the documents and information can be found on the FCA website, and it's under the member resources and under safety, and you'll see 10, 12 different files on there that you can review, including all the files that Mike talked about from OSHA, such as the compliance guide, et cetera, et cetera. Thank you all very much. We appreciate